How does your brain work? How does consciousness work? And what about the unconscious parts? What are they doing? And if you knew the answers to these questions, what could you apply to AI? This video is an introduction to Stephen Grossberg's book, Conscious Mind, Resonant Brain, How Each Brain Makes a Mind. This is part 2. We are continuing with chapters 1 and 2. This is the linking mind to brain section. If you like consciousness, this is a fun section. This section is a mix of Grossberg's ideas and my editorial comments. The focus will be, how do we map events in the brain to events in the mind? A few months ago, a Google employee made world headlines when he publicly stated that some of the AIs that he worked on had probably crossed into the realm of being sentient and conscious. I happened to be visiting my doctor at the time, and she asked me what I thought about this. I did my best to assure her that no, there was nothing to this claim. The reality is that most experts on consciousness know almost nothing about computational models of the mind and brain. They're like a preschooler on their mother's knees. They don't comprehend it. Their thinking isn't much more sophisticated than, if it looks like magic, it must be magic. As I look to the future, my hope is that this will change. Over the past 500 years, computational, mechanistic models have been breathtaking in their power and success. There was Copernicus, who showed us that the Earth goes around the sun, and Newton, who gave us calculus and physics, and Faraday, who gave us electromagnetic fields. And then there was Maxwell, who developed the equations for those fields. And there was Einstein and relativity, quantum mechanics, modern chemistry, biology, and from all these sprung cars and planes and rockets and transistors and computers and the internet. By any standard, computational and mechanistic models have been awesome. If you're like me, then you believe that now is the time for the brain sciences. This is the age when we will work out at a computational level how the brain works. I know this is controversial in some circles, but I see no reason to doubt that we are living in a golden age of brain sciences. This is the time and era when we are unraveling many of the most important secrets of the brain. And this is a season when many of the greatest scientists in neuroscience, psychology, and AI walk the earth. This doesn't mean that there isn't a lot of smoke and loud noises and confusion going on. There is. But it does mean that there's a lot of great work being done by a lot of great, talented people. As we make our way through these developments, no one should doubt that the technical, economic, and philosophical impacts will be immense. Eventually, computational, mechanistic models like Stephen Grossberg's will mature to the point where they touch every person and every corner of the world, every bit as much as anything that came before. It will affect economics and cultures and religions and politics, the very purpose and organizations of governments, and billions of people on Earth will respond by changing how they define success and failure in their personal lives. Eventually, these developments will recolor everything that you know or believe to be true. Eventually, they will force a redefinition of what it means to be human. But that's all in the future. Today, I would like to say a few words about the philosophy behind mechanistic models of the brain. Philosophically, I would describe Grossberg as a physicalist. In the brain sciences, physicalism is the philosophy that the brain creates the mind. Towards this end, Grossberg outlines a mechanistic model for seeing, recognizing, and reaching. A mechanistic model for hearing and understanding and speaking. A mechanistic model for feeling and directing one's actions towards valued goals. A mechanistic model for knowing. And Grossberg provides a linking hypothesis to how conscious brain states map to the mind. This includes models that differentiate between neural circuits that support consciousness and neural circuits that are unconscious. Now, Grossberg doesn't say what the mind actually is, but he does say that his models strongly predict a straightforward mapping between brain and mind. That is, the brain creates the mind. Notice that this is the same sense as a physicist might understand gravity, without actually knowing what gravity is. In this sense, Grossberg is saying that he understands consciousness. Now, there are many philosophers like Daniel Dennett who claim that once we have a solid model of the neural basis of consciousness, we know everything there is to know. On this topic, Grossberg simply writes that he will not deter them. I think Grossberg's approach is sensible. I like his approach. It allows all to walk right up to the very edge of the explanatory gulf between brain and mind. For some people, there are no more questions. For others, there are many questions. For myself, personally, I fall into the camp that has more questions to ask. To me, the mind, qualia, and experience, those are central questions about reality. It's not an afterthought. If it wasn't for qualia and mental experience, we would all be zombies, annoying machines doing clever things. I think it's stunningly wonderful that I'm alive and aware of what's happening to me. Just thinking about it is a treasure that brings me joy. And I'm so glad to be here to enjoy this. Without it, we might as well be dead. Therefore, I like how the philosopher David Chalmers approaches the question of qualia. Chalmers is famous for saying that there is an easy problem of consciousness and a hard problem of consciousness. The easy problem of consciousness is, how does the brain work? Of course, that's not an easy problem, but it's much easier than the hard problem. The hard problem of consciousness is, why do I have a mind? Why do I experience qualia? Chalmers argues that it is one thing to explain what the brain does and another to explain why the brain as a whole has a mental experience. In this philosophical arena of ideas, I see more questions than answers. Each approach has challenges that remain to be worked. For me, the hard problem of consciousness really is a hard problem. Since every approach I know of has open questions, I hope you'll bear with me if I favor physicalism for explaining the easy problem of consciousness and some to-be-determined flavor of dualism for explaining the hard problem of consciousness. And yes, there is an explanatory gap between the two. The universe is built on the foundation of causation. Therefore, in the end, everything must be made out of something that follows the laws of physics. And that includes the mind. It would be silly to think that science has come this far, to only come this far, and then the wheels fell off. Although dualism is a minority view, I like it because mechanistic models of conscious states, like Grossberg's, tend to take the form of a distributed system composed of multiple neuronal fields, suggesting to me that the answer to the hard problem of consciousness must also be in terms of a field. Dualism best describes what I experience. It feels like I have two parts. It feels like I have a body and a mind. And it feels like I'm an agent with the ability to make choices. Regardless of where you might land philosophically on the easy and hard problems of consciousness, it's clear that as mechanistic models of the brain grow in number and mature in sophistication, they'll become an unstoppable force, absolutely unstoppable, in redefining our understanding of consciousness, both the easy and hard problems of consciousness. A couple trends are obvious. First, doctors, psychologists, neuroscience, and others in the brain sciences will tend to consider all of consciousness a solved problem. They'll focus on finding better mechanistic treatments for brain problems, and they'll focus on building common models and common vocabulary, just like physicists and chemists do today. Observation 2 is that the curious, the philosophers, and the religious will continue working on the hard problem of consciousness. They'll increasingly start with mechanistic neural states of consciousness, and they'll seek to explain why a fraction of the resonating brain gives rise to a mind. I like Grossberg's mind-to-brain linking hypothesis because it strengthens the foundations of this line of thinking, and it puts constraints on what the final answers must look like. This is the AI section. The purpose of this section is to talk about how Grossberg's work can be applied to AI. These are my thoughts, not Grossberg's. What does it mean to simulate consciousness? Can a machine be conscious? In what sense? This is a big question, and just as challenging as the question, what is reality? In fact, this really is a fundamental question about what is reality. The motivating idea is that if people are machines that process information, then we ought to be able to build machines that do the same. One way to approach this problem is as two parts, the easy problem of consciousness and the hard problem of consciousness. In terms of the easy problem of consciousness, based upon Grossberg's models, the answer is yes. Conscious states can be simulated. But what about the hard problem of consciousness? Can a digital machine feel qualia? Can it have a mind? Well, you can't just ask the machine if it's conscious. because even if the machine has no mind, if the mathematics work, then you would expect the machine to reply that yes, it was phenomenally conscious. I think there's a way out of this dilemma. In the future, I can imagine a straightforward way that this could be tested. Imagine a technology that would enable one to add a neural prosthetic to the brain. This could be a new capability such as seeing and recognizing objects from sonar like a bat, or it could be repairing a brain that's been destroyed by an accident or by stroke. The idea is that then you can just ask the person how the device changes their experience. But you must notice that by Grossberg's model of consciousness, this neuroprosthetic must be much more sophisticated than a cochlear implant for hearing or a neural link device for seeing. As I've mentioned, Grossberg says that consciousness is an adaptive resonance between two or more fields, where the fields also happen to be at an interface that can drive a decision or an action. The current level of brain implants are a simple feed-forward connection to a small field of neurons. There is no resonance at this interface. Therefore, the resonance, conscious perception, must occur someplace else in the brain. The reality is that even the simplest conscious experience that you can imagine is going to require many different cortical and subcortical regions. For example, imagine that you have a condition of blind sight. That is, you're blind, but like a rookie Jedi, you might have some ability to consciously guess at what objects are around you and where they might be. In this case, if you want to restore conscious sight, you need to replace not just one vision area, but several vision areas. And each of these several areas need to tie into several downstream vision areas. You might need neural circuits for color vision, motion vision, attention to color, attention to motion, and these areas need to be interconnected to simulate a resonance. And then they also need to be connected to other areas like the inferior temporal cortex, the parietal cortex, the thalamus, and the basal ganglia. The idea is that you're not just adding a sensory input, but recreating the circuitry for the entire qualia experience. Imagine being able to see sonar like a bat, but the sonar comes as the experience of a new color, a color that you've never seen before. It's a new color absolutely unique to sonar. If you can explain with a model why red gives you the experience of red, then why can't you have or create a novel color never before experienced before? And there's another strange, weird idea wrapped up with this thought experiment. What if the neuroprosthetic can restore functionality without restoring the conscious experience? Imagine being able to drive a car or play catch with a baseball without actually seeing. You simply recognize, like the blindfolded Jedi, what things are and where they must be. This straightforward approach to testing machine consciousness is currently impossible, but it's still an illuminating thought experience as it gives you a taste for how challenging it will be to integrate synthetically generated consciousness into the brain. It also helps one to develop deeper insight into what consciousness is at a mechanistic level. Given that a straightforward approach to testing machine phenomenal consciousness is currently impossible, I have three observations that I use to reason that digital machine simulated consciousness will never experience a mind. Again, these are my thoughts, not Grossberg's. The first observation is the more that we learn about neuroscience in the brain, the more challenging it is to explain why the brain should feel inequality at all. If the math and the architecture work, then there is no need to experience what it's like to see color. If it's just differential equations, then why aren't we all zombies inside? As I mentioned earlier, Grossberg does suggest a clarifying insight. He writes that we consciously see and we consciously recognize so that we can reach. This helps to explain where the phenomenal experience exists, but the question of why it exists still remains. No one knows the answer. But one plausible reason lies in the physics of the brain itself. The second observation is that if you simulate conscious states on the computer, then everything about the digital platform is alien to the brain platform. The two are totally different architectures. The only thing that is the same is the end computation. And when I stand back and consider that on a computer it's just numbers being shuffled around, I can accept that a sophisticated program can act intelligently and it can demonstrate understanding. but I can't imagine numbers resonating in an adaptive resonance could generate the experience of having a mind. The problem is even harder than that, because you have to also explain why only a subset of the numbers being shuffled around on a computer are conscious. Therefore, as Christopher Koch would say, just as there is a difference between a black hole and a simulation of a black hole, there's a difference between conscious experience by the brain and simulated consciousness. My takeaway from this is this: the baby smile that warms the mother's heart could all be described by differential equations, but that doesn't mean that the math alone has the power to create qualia. In addition, I find a danger lurking in this example, and I would like to provide a warning. The danger is that a mathematical description of a thing is not the same as the thing. The danger is that we are at risk of creating prisons for our own mind if we confuse a description of a thing with the actual thing. As Alan Watts has said, it's the danger of confusing the menu with the meal. I have a third observation. Grossberg proposes that his differential equations and on-center, off-surround network describe not just the brain, but they capture universal properties of many systems in this universe. All of these are complex, adaptive systems, capable of unexpectedly clever adaptation, and most people would agree that there's not a conscious mind behind them. What if Grossberg's equations that model brain states could also be used to model the regulatory system of a developing sea urchin? See Chapter 17 of Grossberg's book. Or how about an economic marketplace? I'm thinking in terms of a complex, multi-level commodities market. Or how about an ecosystem, a food web, or an ant colony? Or perhaps a bureaucracy like a government. In the US, there are 3 branches of the federal government with checks and balances. What if you could organize a government to be more like a brain? In the brain, there's no one neuron in charge. What if you could organize a government in terms of 100,000 branches with checks and balances patterned after the brain? When I stand back and squint my eyes at the breadth of platforms that have the potential of simulating aspects of brain states and conscious states, it's difficult to explain why any of them would generate the experience of conscious qualia. My point is that if we can agree on the mechanistic models, mathematical models of consciousness and conscious states, the day might come when we recognize the computation of conscious states in many places of the universe, but we see most of them as lacking causal power to create a mind. As an engineer working with computers, I like this line of thinking. If there's no qualia inside a machine, it simplifies the ethical concerns. For example, in a far, far future day, no matter how sophisticated the AIs become, I should be able to turn the AI off and throw it away anytime I want, because inside is a zombie grinding through differential equations. There is no mind. In conclusion, we've covered a lot of ground. This has been a review of Chapter 1 and 2 of Stephen Grossberg's book, Conscious Mind, Resonant Brain: How Each Brain Makes a Mind. Grossberg models behavior with differential equations that are tied to plausible neuroscience models. As the models grow in sophistication, he systematically builds a linking hypothesis to describe how the mind links to the brain. In this model, the fundamental unit of information is a field. The fundamental unit of consciousness is a resonance between 2 or more fields. Based upon Grossberg's models, I've speculated on the nature of consciousness and its application to AI. I've suggested that it would be a mistake to confuse the mathematical simulation of conscious states with biological consciousness. And I've argued that a silicon AI with simulated conscious states would not have a mind, but rather be a zombie. If true, the implication is that the human mind cannot be uploaded to a cloud, and conscious brain states can be simulated on a computer, but qualia cannot.